My topic is about the security with GitOps. We have been seeing various, uh, you know, uh, GitOps practices and everything, but yeah, my the major security related things have been. I hope my screen is visible.
Yes, we can see
Hello.
your slides. We can see your slides.
Yeah. Okay. About myself, already a brief description by Scott. That was nice, and I currently work as a chapter lead DevSecOps at EPAM Systems, and previously to this, I also worked in Mercedes Benz for ETL DevOps and those kind of regular cloud and DevOps job job task, and I've been practicing DevSecOps and GitOps. Particularly, I use Argo CD for GitOps, and today we will talk about a few best practices that we should follow because in GitOps we know that our single source of truth is the Git repository where our code base resides, and any changes that we make, it will be visible on the Kubernetes cluster because the automated function of Argo or any GitOps tool is to apply all the manifest or however it is configured. So these are few of the agendas that I have set for this particular talk, and why GitOps alone isn't secured by default. Yes, definitely. We'll be talking about like why GitOps is just an automation tool. We know that an operations of your Git system, whether it is Bitbucket or any provided by any organization like Bitbucket or GitHub, GitLab, GitOps is just a tool. It is not secured by default. So what are the best practices then? So I have I have prepared some modern pipelines and what are some security breaks in GitOps and how to embed security in the GitOps workflows and in a shift left manner, which is a secured development right early in this stage. It's not should be it shouldn't be like that all the things have been done and then we are thinking about the security and all those stuff because the code has been checked in, and if you don't have any security measures, for example, scanning, SAST and DAST scanning of the code and the application, then already the damage has been done because your CVs will be detected, and it's a nightmare that you see anything CVs detected in your production workflows or your application that is deployed in production. How to secure the supply chain with policy as code. I'll be also talking about Kyverno. I have been uh, contributing to Kyverno and Falco. These are both security tools uh, that is there. Falco is by it was contributed by Sysdig team, and today also the maintainers are from Sysdig. There are some tooling landscape that need to be followed for this kind of setup for having security right from the code scanning and your application. So we have runtime security and we have static analysis of the code as well using Sonar Cube and all those things. And I'll be also having a demo architecture that how it should look like. And lastly, we'll be following up with Q&A if you have any questions for uh, related to this the talk that we are having related to security in GitOps. So the first is why GitOps isn't secure by default. It just ensures the consistency, not security. It was when GitOps as a tool like Flux or Argo CD was written by the community. Uh, Security was not the central topic where why it was created. It was just a consistency mechanism in which everything we have a single source of truth on our Git repository, whether it is on online or some private VCS we have as a version control system. So I have a single repository where everything is already there, and I whatever I push, my GitOps tool should take it like what is the desired state and what is the current state. And if there is any state change, for example, anyone who has done by mistake, he has deleted some object or a policy for a Kubernetes cluster or anything like that. I definitely don't want that in my production cluster. And my GitOps tool like Argo will try to bring the state again in a consistent fashion. So all the misconfigurations and secrets can still be committed. Yeah, it is because by default, as GitOps isn't secure, any misconfiguration, for example, if you have certain policy in your cluster in which you want to you just don't want to allow your images to be deployed with some certain tags. For example, the latest tags of image may or may not be secured. They might not be following those security best practices, how the Docker file for those image artifact are actually written. Maybe the base image would have some CVEs, and that's why when we go with any deployment of any container or images, lastly we deploy the images in the Kubernetes cluster. So you see that we don't actually, it's not a best practice to go with the latest tag of any artifact. We choose something which is stable, has a patch version of it if it had some CVs. So we have to select something with a certain tag, so that the artifact which is deployed is free of any CVEs or any vulnerability that can pose. So security tooling is often a post facto in GitOps. I have seen myself that security is the last thing. Generally, in any company, infosec team is if it is a mid-sized company for 100, 200, or 300 guys are there, and I have seen that only two or three guys maybe in the infosec company who takes care of all these things. But in production, when the damage has already been done in production, it becomes really a huge task to implement the security right from the start. So in my idea, we should have shift left security right from the early development or DevOps activity in the organization. And for an example, GitOps push a deploy an app with the critical CV. It's a normal thing that we have seen, and that is why in our GitOps, maybe if you're using some CI like GitHub Actions or Jenkins, or if you have any testing or security scanning step or a stage in your CI. For example, Trivi scan. When we do a Trivi scan for all the images, if it has any CVs, it will detect and generate a report. And normally we see it in the production when the image artifact is not updated or it is not with the compliancing if that is required, for example FIPS or NIST standards. So those have some may have some CVEs, and for that you need to actually put up a scanning or some kind of a stage so that everything is up to date and also free of any CVEs. So DevSecOps, how this brings security by design, shift left, as I mentioned, that integrating security early in the stage. For example, your CI building stage itself, if you have, let's say you have GitHub Actions in which the moment the code is committed and pushed, you should have branch protection rule as well, because GitOps is everything is your Git repository, and you have certain branch which is which your Argo CD or any GitOps tool is actually added, or you have created an application which is setting up this repo, watching this repo with polling, and it polls any changes with it, and that's that. I mean, with by uh, I mean, this is a very early stage of activity that we should do it, because GitOps will try to deploy anything that is uh, that is how you have created your application. And we'll be also I'll be showing it through a very small demo how it does and how it can actually save such kind of a scenarios. For your security, it should not be a manual effort. That is why DevSecOps has played a major role in this security thing today in the market, and we should be having some mindset in us that when we are while we are deploying anything, and we should automate everything so that there is the they should be the least attack surface, because if manual intervention is there, the chances are like that some security bug or CVE can be pushed to the production, which is next to a nightmare activity that should not happen. So like our CI system, how it should have proper test stage, it should have a scanning stage, and you should have quality gates with, let's say, your Sonar Cube or any other scanning tool you have. For secure code, you should have SAST, like some uh, static code analysis using semgrep. If you have an IAC code, for example, if you're having Terraform code, if you're doing versioning of your Terraform files for infrastructure as a code uh, file to create your infrastructure, or if you're maintaining your infrastructure through IAC, then you should use Checkov. It's a nice security tool which helps you to detect any kind of a misconfiguration or any security vulnerability or such kind of issues. Coming to the images, then you should have Privy scan, Privy or from Aqua Security. If you're using GitHub Actions, then you have nice already created GitHub Action attributes, certain actions which are already there. So you can use Aqua Security GitHub Action attributes that will help you to scan your images properly, and even you can also upload the JSON file or the artifact, which is your scanned artifact, the scan report, and you can store it even if it is you want to store it for future reference, or if you want to also do some security activity, for example, just removing the CVs from the images, so you can also store that. And you should have proper pipelines in which your code is scanned, and then there is a build step. So right after the scanning of the Docker file, and right after the creation of the Docker image, it should also scan before pushing to the Docker registry. It can be ACR, ECR, or whichever container registry the company follows. And similarly, for clusters, you should have some policy engine, for example, OPA, gatekeepers, or Kyverno. I happen to use Kyverno because this is really a nice project on security for policing the clusters. But we can trust on start or the initiation of a project, but we should verify the policies, validation, and even monitor the things if it is going something is going awry, or if there is any such kind of an issue, we should have proper alerting mechanism as well. For example, a Falco does a great job in this. We can even set alerts based on any such kind of a security. So where GitOps security actually fails, you see there is a lack of policy control before applying manifests. There's no policy before you are applying such kind of a manifest. I've seen in production clusters, various companies that even product companies that there was no policy into the clusters, and there was no such kind of validation policies, or cluster policies in which it should detect those changes, and even it can stop you. I mean, stopping before taking those kind of action. For example, if I create a pod with latest tag, or some CV is there, or it is not stored, it is not coming from Docker, a certain registry. Even I've seen that people can, even in production clusters, they have been pushing images from Docker Hub or other registries. So that shouldn't be there. It should be configured. Your Kubernetes cluster should be configured in a way so that it pulls the images from certain private repositories only. Uh, there can be a scenario where you are installing Helm charts, and Helm charts will try to, you won't even know that in those Helm charts where the images are getting pulled off, maybe Docker Hub or any other source, but we can parameterize it using Helm values.yaml file, and we can configure those scenarios. Those are edge cases that we can take on. But all in all, I want to mention that in the cluster, these all basic security principles or security policies should exist, and the common policy must exist, and you should have protected branches as well. For example, let's talk about how we can policize our own cluster. We have Kyverno policies, the certain cluster policies and certain app and these objects which Kyverno provides. And if you see them, these all policies can exist in. So if you see how the secure GitOps workflow architecture should look like, it's an example flow of the things or chain of events in any automated CI/CD setup. Some while I was mentioning about the target revision, there is a when we create a cluster policy or the for Kyber node, it should reside in one of the branches or a separate repo, and we can create a separate app for just creating policies on the cluster. And when you see when you're creating an app, an Argo City app, there is a certain under
Sorry,
spec you have a target.
sorry, Arpit.
Yeah.
Just the screen share also stopped. Thanks.
Yeah, okay. So the you see that I was mentioning about target revision. This is the normal application uh, with which you create an application. You add your repo which you want to watch, and there is a target revision. So target revision can have you can even specify a particular branch or particular head you can say, or also a certain name of your branch head or even commit a particular commit also you can mention with target revision. And path is like under a repo a certain directory or certain path where you want to watch it. If any change happen in certain path, then only GitOps will take some action if it is Argo CD or Flux or any other Git. Then if you see how target revision will help you, this is a common scenario in which all your policies should exist within your some private cluster policy or certain another repo as well, in which all of your Kyverno policies YAML can exist. Why I am pressing or emphasizing on this certain point is, let's say by any manner or even somebody by mistake, if he log into the cluster, a production cluster, and deletes a certain policy, then also if these policies are existing as your GitOps application and with your GitHub repo, even if the cluster policy is deleted manually, but your GitOps will try to bring it again. So your policies will always exist in the cluster. And as you can see that how this application is maintaining all the policies. You can have n number of cluster policies, and that you can mention and you can create those manifests, and those policies will exist. So manual PRs, yeah, there are some security breaches that happen, and like manual PRs are missing. Branch protection rules, classic, or whether your custom rules are missing, your security validations are also missing in that case. Your secrets, normally I've seen people use the secrets under Git repository only under settings, and they create the GitHub or GitLab secrets, and then they refer it to their GitHub CI/CD pipeline or wherever required, and that shouldn't be there. Or insecure vault integration itself. There is no image scanning in the workflow. I've seen people running, the jobs and without no scanning of the workflow or the images. That shouldn't be done. And even I've there's a common scenario that you won't find any RBAC or audit trail for the GitOps tool. YDC integration isn't there. People use some ad hoc IAM role or service principal for the CI to run your job. Directly to maybe cloud or EKS or any other platform. If you want to run your CI, you should have OpenID Connect or something like that, so that the token that is required, it is very short lived, and hence it is secured. Because it just gives you 2 or 3 seconds when the job is done, the OIDC token is removed. So it cannot be, any person with malicious intention will not be able to use that particular token. So that's a security measure that we need to follow. And this is a very, there's a very sample. I am not hard pressed that everyone should follow such kind of a architecture. But this is just a general architecture that we can follow, where developers, they commit the code to their GitHub repository. It may be an infrastructure as a code or something related to the application. Your CI/CD pipeline will run your automated testing, building, pushing, and everything will do, which is your CI stage. After that, while your static code analysis and dynamic code analysis also should be integrated within your CI pipeline only as a separate stage, or it can be another a downstream job as well. When your code is committed or pushed, the moment it is pushed, your SAST, let's say if you're using Bandit, or if you're using Checkov for your IAC, if you're using uh, there is one semgrep also can be used for any static code analysis for in place. And this, after your security scanning is done, there are some steps to do it. Check off semgrep, and then you even scan your image before pushing to the repository. Your GitOps controller will try to poll it all those changes, and there is a state reconciliation happens, and then you deploy it. Whichever environment that was used. And the separation is this can be done from the gate level only, like what workflow you are using. Maybe trunk based if it is a IOC kind of code. If it is a open source, if you are as an open source developer or open source contributor, you might follow a fork workflow in which you fork a repository, you do some development, and then you create a PR. So based on that, these separations are there. Even environment separation is there if you're using GitLab or GitHub style of workflow. Then also it can this kind of a setup we can have it. So right from the security GitOps flow, how it should be: you code, you push it, and then you have some test automation suites and all those kind of job already written as a stage. This can run. This will, after this testing is done, code smell, or the static analysis when done, this will create a build and a push to some as an artifact. We are in DevOps or in Kubernetes environment. Definitely, you will be holding the Docker images, and it should be scanned before getting pushed, and then it should go for a CD stage. So from here, you can see it's a continuous deployment that you deploy it and you monitor, and then the whole chain completes, and then you repeat. So that's how it's. So there are some steps that I have written, some 6 points how we can embed the DevSecOps in GitOps. We can have pre-commit hooks for secret scanning. Pre-commit hook is a very initial stage of security step. We can have with our GitHub CI/CD or GitHub Action, if you're using, we can have other types of security scanning as well. As I was mentioning in the previous slides, we have PR checks as well. Whenever any pull request is created, there are reviewers should be added, and these checks should have something with static analysis of the code, ISA scanning using checkoff, or dependency checks. Even we have nice tools. If it is a Python, we can use Bandit to check the dependency checks as well, whether they are compliant or not. Then we have policy as code, as mentioned. We can use OPA, now deprecated, but today we use Kaiwano very often. So I think we should use Kaiwano for policing our clusters. We should use signed artifacts. We can use cosign. We can even use verify gates with GitOps, and to find the artifacts and then deploy it. Our admission controllers should be configured in a way that stop the misconfiguration apps to be deployed. And for secret management, I think we should use sealed secrets by Vault or Hashiko Vault or any cloud provided secret managers, for the KMS or Azure Vault if you're using Azure, or and certain drivers should be installed in the cluster so that any object that you create in the vault, this can be integrated within your Kubernetes clusters. So coming to tooling landscape, then this is a whole lot of tooling landscape that I was mentioning, and this is the case study that I followed for while I was maintaining whole 25 plus Kubernetes clusters, and even introduced Kyverno for verification. Argo CD, because I had 25 clusters, so I had one central management cluster and I had spoke clusters. So I used Argo CD and integrated with Cosine and Trivi. CVE exposure was really less by 85%. The InfoSec team was really happy because they didn't have to go through all rigorous exercises of management and CVE's detection. And this is a fast security feedback loop. Yeah, if you have DevOps and DevSecOps in place, this happens. So these are all the some best practices. And implement secret scanning early. And yeah, we have these some points. And yeah, these are the takeaways. GitOps need DevSecOps by secure by design. Use policy gates to fail early, fail safe. Citizen build secure workflow, not just secure the code. Yeah. So yeah, I'm done with the security, this thing DevSecOps into GitOps. If you have any questions, you can put it up. I can answer that. And I'm actively very active on LinkedIn. Even I created some sample project as well. Even for this talk, I had a sample project, but due to the time is already up, so I couldn't showcase that. If you have any question, you can even ping me on Slack if you require. So yeah,
Awesome. Thank you
thanks a
so
lot.
much, Arpit. It was really great to have you here.
Yeah,
And
thanks a
yes,
lot.
yeah, and yeah, please, yeah, definitely we can follow up in the Q&A and in the chat here, and on the
Yeah,
Open GitOps Slack.
sure. Thanks.
Thank you.